Good morning, geometry students. We're getting ready to take a look here at spheres and their geometry. One of our most important spheres in our lives, or at least an almost sphere, is the Earth. So we're going to be spending some time today looking at our Earth and our globe. Normally, I would be able to show you on the globe that I walk around and point to and um, put a little bit of actual uh, hands-on for this, but since we can't, thankfully the people at EduMedia have decided to, during this crisis, allow us access to a globe that I can do a really good job of showing you some things on right here. So we're going to take a look at these things, and I did get your questions. Thank you for submitting your questions on assignment 55. A little bit later, I'm going to spend a little time and make a question answering video, and I'll put that up. I'll put a link up for that. Now, the question answering video is for those of you that have questions, but these original ones that explain about a topic, those are mandatory. But you know what questions you asked, so there's some things on the homeworks that just need some clarification for some of you that asked the questions. And for those that didn't ask the questions, you might want to watch it anyway because people asked really good questions. All right, so on a globe, we want to be able to think about our longitude and latitude lines. And I believe that you've probably had this in history class already, geography. Um, But just from a geometric standpoint, that's where these things come from. So what you'll notice is that you have lines that go completely around the Earth, okay? These are our longitude lines, okay? The longitude lines going completely all the way around the fat part of the Earth. The other one is just the one special latitude line known as the equator. Okay, the equator, if we look at the world from the top, the equator is the only great circle on the latitude lines. On the longitude lines, all of them are great circles which go all the way around. Great circle is probably your new vocabulary word. Um, so I'm just putting that out there. The equator is our horizontal great circle that goes all the way around. And then there are smaller circles. If we come back to here, okay, and the smaller circles, as we go further and further up, okay, these circles on the flat map are these lines, okay. Now they do have to mess with the proportions when they make a flat map like this, okay, because as you can see on the actual globe, the circles are getting smaller and smaller and smaller, and that's just the way that it has to be. So we have our smaller and smaller circles, one great circle on our latitude lines, and on the longitude lines, they're all great circles. Okay, now sometimes people have trouble telling the difference between latitude and longitude. And if you just right now, and you're gonna, some of you will do this and some won't, but I'm just telling you, if you want to know which one are the latitude ones, when you say latitude, your mouth goes sideways. Okay, so the latitude ones are the ones that go like this, and the longitude ones, if you say the word longitude and you actually say it, your mouth goes up and down. So those are the longitude ones. That's always how I remember the difference between latitude sideways and longitude up and down. So that's just a little trick for you that it's it's an interesting little trick that helps you to remember the difference between the latitude and the longitude. Latitude, mouth goes sideways. Longitude, mouth goes up and down. All right, let's get back to this. Okay, so the smaller horizontal circles as they go along. Now the number of degrees is an interesting thing to think about. This comes from our geometry idea. Okay, so the smaller circles as you go up or as you go down give you latitude lines that go from 0 to 90. And let's think from a geometry perspective why it's from 0 to 90. Okay, so we've got our equator that's going around the center. It's our great circle. Okay, so I'm just going to take this point P right here and go down, and this point will show up wherever I put it. I'll put it down here. Okay, so here we are at our equator. We're at 0 degrees. Okay, and I can show this very nicely this way. And as I go up here, I'm going up to 15 degrees. Okay, and let's think about where that is. If you can imagine a point right in the center of the sphere, and it goes out here, the angle that goes from the central angle that starts in the center and goes to the equator. I'm having trouble getting this lined up just right. There we go. Goes across the equator and then comes out from that center that goes to point P would be a 15-degree angle. If I move P up a little bit, I move it to 30 degrees. Okay, there we go. We can still see it, the angle that goes from the center and comes out here. I think it's going to let me draw. Yeah, I'm going to get to draw here. So we've got this. So we have this, ooh, bad drawing, but at least it's a drawing. So this angle here would be 30 degrees. Okay. If I were then to take this and move it up again, we go here. Okay, we can't see it, but let me turn our world just a little bit so we can see it. There it is. And it's a little difficult to see what's happening here, but here would be our 45 degrees. Okay, and that might be making some sense to you. So there would be 45 degrees. All right, so what's happening, and then you go all the way up, and the very, very tip top of the world would be at 90 degrees, and you'd be able to kind of see that. So that's where we're getting our 15, 30, 45, 90 as we go up and down here. Okay. So down here, here's our 0 latitude, and then 15 latitude, 30 latitude, 45, and I know it's not showing up very good on the globe here, but there's our 45 and our 60 degrees, and so on and so forth. So when you are doing these things, you're thinking about, oh, okay, so that relates to my geometry, it relates to my angles. Okay, now if you'll notice on the longitude lines, it's going from 0 and then it goes all the way to from 100 to 180. Okay, so if we start at 0, 0 is a special place. Okay, and Marvel fans might actually have a better handle on this one, because if we look at 0 degrees, trying to get that, there we go, and at about 51.5 degrees north latitude, and at 0 degrees, there's a country in England called Greenwich. Okay, and Greenwich is basically where they start the time. Everything is based on Greenwich Mean Time. If you're going to all the different time zones, there's certain distances away from Greenwich, England. So that line that goes through Greenwich, England is called the prime meridian. Okay, and it is where in the world 0 degrees longitude has been designated. Okay, so 0 degrees longitude is what we call the prime meridian. It is the great circle that goes through Greenwich, England. Okay, the prime meridian. Now the thing is that's very interesting, that if you bring this around to the other side of the world, okay, and I'm just going to bring that right around to the complete opposite side of the world. Okay, you're heading along the great circle. This one's at 0. The other one is at 180 degrees. Okay, think about this. If this is at 0 degrees and you come all the way around here, you get to 180 degrees. And this line is super important. Okay, let's see if I can get this right here. This line right here is called the international date line. And on one side of it, it is 1 day, and on the other side of it is another day. And that's a whole other discussion. Make sure that you find out about that in your geography class. But we have the international date line that's at 180 degrees on our longitude markings. Okay, so the international date line, very convenient that it really doesn't hit land masses. That's on purpose so that you don't have somebody walking from one day to another. But international date line is at 180, and our prime meridian is on the other side of that. Okay, so we've got 0 degrees and then all the way up to 180 degrees when we're talking about our longitudes, but our latitudes only go from 0 to 90 north and 0 to 90 south. Okay, and that's because those latitude lines are not all great circles. Great circles go all the way around. Okay, so I haven't really taught you anything as far as calculating yet, but you needed to really understand all that before we could calculate. Okay, our Earth is divided up by this prime meridian and the equator, and those are our main dividing into different places. They're divided into hemispheres. We have a northern hemisphere and we have a southern hemisphere. Hemi meaning half, so half, and you've heard about northern and southern hemisphere. We also have an eastern and a western hemisphere, and that's divided up by this prime meridian. Okay, it's divided up by that imaginary line that goes through Greenwich, England. Okay, so we have the eastern hemisphere and the western hemisphere. The eastern hemisphere and the western hemisphere. So the Earth is really, when it's being discussed in any kind of framework, it's divided up into 4 sections: the northeast, the northwest, the southeast, and the southwest. Okay, so here's this. Okay, all of the countries that are north of the equator are northern hemisphere, and then eastern hemisphere, northern hemisphere, western, northwest, and it divides it up like that. So that's an interesting thing to think about. Now what we're interested in is these degree numbers. Okay, I have here in my instruction, we'd be examining the globe and taking a look at it in class, but we can take a look and get some basic ideas on our world map here. If we're talking about where Florida is, if I move this down here, okay, Florida is at about 81 degrees longitude this way, 81 degrees west. So that means that if we look at where our Greenwich, England was, where our 0 line was, we're going west of that 81 degrees. That's our longitude, and our latitude would be going up from the equator 28 degrees. And that's where Florida is. If we look over here in Australia, and you could get more specific on that. I'm just going by this map that we have with this very, very nice resource here. So we have our equator. Okay, if we're comparing it to where Greenwich, England was, which was on this line right here, okay, we would be going in the east direction. So 143 degrees east takes us to here, and then south latitude 25 degrees south. So 25 degrees south and 143 degrees this way. So we're working with the globe, the actual globe, but you can think of it as being a flattened out map like this. Okay, so that's hopefully helpful to you. You can go by, sometimes on your GPS systems that you've got on your phone, it'll give you longitude and latitude, and not sure how helpful that is, but what that's used for is that it can then calculate distances, and we want to just take a look a little bit about how those distances are calculated. Something that if you want to get more specific, yes, we use decimals a lot, but one of the ways that it is divided up, degrees are not the finest measurement, and like 30.6 degrees, like on our interactive map here, that's getting to be more and more standard. But there are minutes and seconds that can also be breakdowns of degrees, and they are just like they sound. Okay, just like in time, minutes is a part of an hour. Okay, there are 60 minutes in a degree, and just like seconds are part of minutes, and here seconds are also parts of minutes. Oh, sorry about that. My dog has great celebrations when anybody ever moves in our household. So now I am back. So what I was saying before the dog decided to bark super loudly is that degrees can be broken down into minutes and seconds, just like minutes and seconds are part of our time measurement as compared to an hour. So 15 minutes would be a quarter of a degree, and 20 seconds would be 20 seconds as a piece of a minute. Think about time, and then should make sense to you. Here we're finally going to get to do some calculations, the rest of it just so that you could understand our context. Okay, so if I have this thing and I'm trying to read this, I would read this as 30 degrees, 15 minutes, 20 seconds, just as I said a moment ago. 1 minute is 1/60th of a degree, and 1 second is 1/3600th of a degree, because there are 60 seconds in a minute. So this is really telling you that there's 3,600 seconds in an hour, 3,600 seconds in a degree. So we can use that, okay? 60 minutes equals 1 degree. 3,600 seconds equals 1 degree. And we can use that then to help us to do some conversions. Okay, because in all practicality, we don't use this so much anymore, so we have to turn it into degrees. Into degrees with decimals. So here's our process for this. Let's break this down a little bit better. Okay. I want to make it into decimal form, and it's not as hard as you might think. I have 30, that's like our whole number, 1. 15/60ths, okay, because this is a part of a whole degree. It's 15/60ths of a degree because there's 60 minutes in a degree. And since there are 3,600 seconds in a degree, this is 20/3600ths. So when you are simplifying this down, you're breaking it into its 3 pieces: the whole number part, the fraction of 60, and the fraction of 3,600. And then you'll let your calculator do the work for you. And you can do this in 3 parts, even with your basic calculator. Here I would take 30 plus 15/60ths plus 20/3600ths. And so all in one step there, we get about 30.26. Although, if we do it in pieces, we can go to the 4th decimal place, which actually is a little safer because we've got all the way down to pieces of 3,600. So we really do need to go to 4 decimal places past the decimal. And we've got kind of like 4 digits, so you can kind of get the idea of how this goes, but in little pieces if you don't do it in big chunks. And let's take a look at a regular calculator for that. Okay, this is on everybody's, so you can do this in pieces. Okay, we have our 30. We have our, let's see if I can make this work. Here we go. 15 divided by 60. There's your 0.25, and your 20 divided by 3600. Oops, too many. Back up. There we go. 0.050056 when we round it appropriately. And then when you add these decimal places together, if you don't want to do it in one swoop, it's actually a little safer to do this. 30.2556. And then you've got all the pieces that you need to rounded to an appropriate decimal place, and I'll be looking for that as well. Okay, so that's your one main concept for this. Now, arc length. Okay, we talked about arc length in another chapter. So you might want to go back and look at arc length if you have a little trouble with this part. But I'm going to review it for you. And we need to apply it now to a great circle. And this is sort of what your GPS is doing. Figuring out pieces of a great circle that goes around, even if it isn't strictly longitude and latitude, and we can figure out where something is compared to another thing. So Budapest, Hungary is near 45 north latitude and 20 east longitude. Honolulu, Hawaii is near 20 north and 160 west. So I want to take a look at this. Let me see if I can. Here we go. And here we go. I want my information to be all near the same place so we can take a look at it together. No, it's not working for me the way I want. All right, so anyway, let's take a look here. I want to go to Budapest, which was at 45 north, 20 east. So let's look at 45 north, 20 east. 45 north up here, and 20 east, which would take me to right, 45 north, 20 east would be about here. Okay, so 45 north, 20 east, I can spin my globe and I can take a look here. Okay, so it's 20 to the east. The other one is 160 west. Okay, so 160 west, when we think about where 160 west is, 160 west would be way over here. 160 west would be on the same great circle, because while this one is found by going 20 east, if I'm going 160 west, that's 180 degrees altogether, the whole opposite side of the world. So that takes us to Hawaii, which doesn't show in this map, but Honolulu would be right on the same great circle on the other side on this map. I actually drew a picture of this to make it a little bit easier. But you get the idea that it comes all the way around here, because this one is going this way, okay, all the way to almost, and we go around the world a little bit to get on this side on this map. So we're getting closer over here. 150 would be out here. 160. But it's out here somewhere. Okay. So what that looks like, because they're on the same great circle, is this picture that I've drawn right here. Here's Honolulu. on one side, and here's Budapest on the other side. This is the equator. So what we have here is we have the longitude lines tell us that they're on the same part of the Great Circle, but our latitude lines give us 20 degrees and 45 degrees. Okay, latitude 20 and 45. They're both north, so they're both up from the equator. And we're going to imagine this line that goes right to the center of the circle and the number of degrees in between, and we're going to use our arc formula. Okay, so here's Honolulu. Notice I didn't have to do special 3D here, and actually the 3D was kind of messing us up a little bit. But here's Honolulu, here's Budapest, and we go to the center of the circle here. So since we're trying to find the arc length, the distance directly from one city to the other, we need to know the number of degrees that are in here. So we want to think about what we know as far as circles go with that. So there'll be 20 degrees here, and there'll be 45 degrees here. Straight up from here makes 90 degrees, right? So I want to find out how far this is and how far this is so I can get the whole distance in here. So if this is 20 right here, it takes me another 70 to get straight up to the North Pole, which is at 90 degrees. 45 degrees along here, another 45 degrees to get us straight up and down, okay, at the top of the Earth. So all together, this arc is made up, has a measurement of 70 plus 45, which is 115 degrees. Okay? And that 115 degrees is important because I need to find the arc length. Okay, remember arc length is different than the measure of the central angle. We're bouncing back to that from the other chapter. So we find the number of degrees between them. You can make a quick drawing of a circle to help you do that. The number of degrees between them. Then you need to use your arc length formula, which I'm reminding you of right here. You might want to re-jot that down. It's the number of degrees compared to 360. It's a part of 360 times the circumference of the whole circle. And the diameter of the Earth is about 7,900 miles. Since the diameter of the Earth is about 7,900 miles, and the circumference formula is pi times diameter. Here's pi times diameter. Remember, circumference pi times diameter. What we can do then is simplify this so that you end up with your answer of about 7,928 miles. So 115 divided by 360, so you can see it happen, times pi times 7,900. So 7,928 miles to the nearest mile. We can do this on a regular calculator too, so you can see this happen all at once. We can do 115. Let me make sure everything's cleared out. 115 divided by 360 times, they don't have a pi on here, so we're going to use about 3.14 times 7,900. Too many. Now, why do you think we have 7,924 here? We have that because we didn't use the actual value for pi. The actual value for pi is important. No, there is a pi on here. So let's go back and do this with pi. I missed seeing that. So you can look around a little bit to find it. So we are a little bit off if you just use the 3.14. But let's do this again. 115 divided by 360 times pi times 7,900. 7,928. So if you have a pi button on whatever calculator you're using, you're going to get a better, closer answer by using that rather than the about 3.14. So do that if possible. Okay, so lots of things talked about today, only a little bit of them calculations, but I hope that all of the talking helped you understand what the numbers are for, where they came from, and that it just makes it a little bit easier for you to see, okay, well, why would this be even useful? Okay, so part of a great circle going all the way around. And when you do that, you can use these degree measurements based on something that we did before. Okay, there we go. There we have it. And a little bit later, I'll be going over those homework questions from assignment 55 that you turned in. So have a really good and blessed day. And I hope to see you really, really soon. I am praying for your prayer requests. And have a good day.